So our first chapter this year is going to be on linear algebra. Linear, if you look, the word line is in linear, so we're talking about the algebra of a straight line, of any kind of straight line. And to start off, we're going to review a little bit about solving systems of equations. And last year you guys learned about systems of equations because a system of equations is two lines. And ideally, those systems of equations will cross somewhere. So ideally, those two lines are going to cross somewhere. They're going to have what we call a point of intersection. So when you're asked to solve a system of equations, you're asking to find the POI, the point of intersection, the point where both of those lines meet, they cross. So there are many ways that you can see these. You can answer the question of solving a system. The first is on a graph. So if you look here at this graph, you see there's a point of intersection right here where the lines cross. And if you give me the answer, the solution, so the answer is going to be always in the form of xy. So the x-axis is always first, the y-axis is always second. And if you look here, you can look at the graph directly, and the point of intersection is at 2, because it starts with the 2, remember the x-axis, 2 and -3. That is the solution. That is the point of intersection. You have solved that system of equation. So then if we move on to the next one, as you can see the pink dot, point P. Remember x is first, so 2, and then y is 2. So that's the point of intersection of this. That is the solution. That is where both of these lines will meet. Graphing's easy. You can just look at it, find out where they cross. But the next one is tables of values, which isn't really an evident solution. So we have our x coordinates, 2, 3, 4, and we have y coordinates. Now if you look, we have y1 and y2 because this is going to be line 1 and line 2 because in a system of equations you have two lines. Now generally, each line, the y coordinates change, but the x coordinates stay the same. That is why we have two y boxes here. So you're going to say, well, miss, I don't know what these are going to look like. I know they're straight lines, but I don't know if they're going up, I don't know if they're going down, I don't know where they are. That doesn't matter. What matters is where are y1 and y2 identical? Because a point of intersection means that both lines have that point. Well, both lines have this point, 1 and 3, 1 and 3. This is the point of intersection. Not more complicated than that. So then if we move on and I just show you if we graph it really quickly. So if we have 0 and 1, so remember the x is first, the y is second, so there's 0 and 1, we put the dot there, and then we do 1 and 3, and then we'll do the first line, 1 and 5, or sorry, 2 and 5. So this is the line for line 1. And if I do line 2, we do 0 and 7. Starts here in the blue dot. And then 1 and 3. And then -1 and 2. You're going to get a line that does this. So there you go. You have your point of intersection. So this is really easy. You can graph these points at any time if you want, if you're unsure. But it's not something you'll see very often this year. The other ways of determining systems of equations and solving you saw last year, and one is called comparison method. Okay, so you have, when you use comparison method, you have two function form, so y equals ax plus b form equations. Remember the a is the slope, b is y-intercept. So here we have two y is equal to x plus b equations. What do? You make them equal to each other. Comparison means y equals y. We compare them. So -100x plus 1900 is equal to -150x plus 2400. So as you can see, the y's aren't there right now, so we are solving for the x variable. When you're finding a point of intersection, you need to find the x-coordinate and the y-coordinate. So right now we're looking for the x-coordinate. So the first thing, so now we're using our algebra. We need to combine like terms. We want all of the x's on one side. So we're going to move that over. So negative 100x plus 50x gives me 50x plus 1900 is equal to 2400. Now we want the 50x to be all by himself, so we're going to move that 1900. To make it 0, we have to subtract. So 2400 minus 1900 gives me 50x is equal to 500. Divide each side by 50. And you get an answer of x is equal to 10. And you can check your answer. And so, if we want to find out what y is equal to, I'll change my color here. If we want to find out what y is equal to, you pick an equation, any one. You can pick the first one or the second one. I'll pick the first. Y is equal to negative 100 times 100 plus 1900. Just put that in your calculator. So negative 100 times 10 plus 1900 gives us an answer of 900. So y is equal to 900. So let's double check this. You can do the second equation. Negative 150 times 10 plus 2400 should give you an answer of 900, and it does. So this works. So my point of intersection is 10 and 900. That's my answer. So we'll do one more example, a little bit smaller numbers. So here again we have two function forms. We have two y equals. So we have to do y equals y. So 2x plus 12 is equal to 4x plus 24. We want to combine our like terms. So we want all the x's to be on the same side of the equal sign. So 12 is equal to 2x plus 24. Now we want the x to be all by himself. So positive 24, what's the opposite? Negative 24, because we want 0. So negative 24. So we get 12 minus 24, which gives me an answer of negative 12 is equal to 2x. Divide each side by 2, because we want x all alone. X is equal to negative 6. So remember, we're finding an x and a y. So we found the x, now we need to find the y. So if I use my blue, and I'll pick the first equation, so I'm going to put an arrow over here because I'm running out of space. Y is equal to 2 times negative 6 plus 12. 2 times negative 6 is equal to negative 12. Plus 12, so negative 12 plus 12 is going to give me an answer of 0. So 0 is our next coordinate. And if we look here, 2, so y would equal to 0. So 4 times negative 6 is equal to negative 24, plus 24 is equal to 0. So this guy works. That's my point of intersection, and that's comparison method. So why couldn't the angle get a loan? Because his parents wouldn't cosine. And that'll make more sense when we talk about trig later on in the year. But if you get it, good job. See you next class.